Hello friends, and welcome to this session where I'm going to talk about evolution of data lake. This is a typical one-tier legacy data lake architecture where the source systems are there at the bottom. These source systems are going to send the data to this data warehouse solution, and then using the SQL query on top of this data warehouse, the data are sent to the different type of dashboards and reports that you have built. Now, typically in those legacy architecture, they are the RDBMS which are capable of storing large amount of data. Generally, they have the indexing which are enabled, not the primary key or the secondary key or even the foreign key. And another peculiar capability of data warehouse is also the dimension and the fact tables. So they support the star schema on this kind of data warehouse solution. Now you can see that there are multiple constraints which are there with this architecture. As I mentioned that data warehouse is a RDBMS solution. This means all the sources that you are taking the data from, they are mainly the SQL data sources. So with the modern age applications where you are also capturing the clickstream data, the machine data, the sensor data, the social data, those data are not available in this data warehouse. Second is there is a constraint in the hardware storage of the data warehouse solution, because generally they are either Microsoft or Oracle data warehouse solution. This kind of solution requires a compute and the storage which are tightly coupled within the same database system. So if you have to scale, you have to scale both of them. That includes additional cost for the hardware as well as for the licenses. You can store terabytes of data, but when the enterprise start thinking about storing all their different data coming from machine, plant, and the other enterprise systems, it may go up even up to the petabyte and exabyte kind of scale. And there, this kind of architecture doesn't work. Third is the schema. When do you define the schema? In this kind of architecture, the data engineers, when they are working on it, during the build time itself, they are thinking about the schema. So even before getting the data ingested into a data warehouse, they had to first understand what kind of reports they are going to generate out of this solution. And based on those requirements, they design the schema. And then only they start ingesting the data from this source system into the data warehouse. Now, because of the limitation of storing only the relational data and not the unstructured or the semi-structured data, it limits what all use cases you can be able to execute out of this architecture. So all of those innovative use cases like AI/ML, advanced analytics, this kind of things you would not be able to execute in this kind of architecture. And finally, the data governance, because with the industry growing and there are a lot of governance which are required, especially in the financial industry and the healthcare, you need very fine-grained access control and the governance of the data. And this is something which is not possible in the data warehouse. I will explain this part slightly in more detail. Suppose in the healthcare industry, you are having the patient data. Now, patient data will have the clinical data, which includes the diagnostic report, the prescriptions, and of historical health record. This data, as long as they are stored in the primary data source, there is no such issue because the data governance are already in place. These data are only accessible by those doctors who really need this kind of information. But now, when you start sending this data into a centralized data warehouse where there are all other data also which are available, and there is a multitude of other stakeholders, other users, data engineers, which are working on this kind of data warehouse, they get access to those data also. So you need to bifurcate those kind of information from the data warehouse solution, which is not possible with this current architecture. And that's the reason there is no governance that you can apply in the data warehouse architecture. Now talk about the modern day architecture which involves the data lake. The first change is on the data source itself. You are now going to have this relational data which was there in your legacy architecture, But then you are going to add all other data sources also. That includes data coming from your IoT devices, data coming from plant, machine health data through the sensors, your social feeds, your clickstream data. All those semi-structured, non-structured data are getting added into the data lake. So data lake is now going to be your main staging area for all the data. So the data lake is now becoming the central place to store all the data. I will explain this complete thing through the architecture flow. So first is your data source. This is the data source which is going to be there. You extract the data from here and directly load this data into the data lake. So this is going to be your data lake here. So first you do the extract, then you do the load, and simply dump all the data into this raw bucket. So you will have a raw zone where you are going to store all the raw data which you are getting from the different systems. So whether it's an audio file, whether it's a video file, whether it's a JSON, text, CSV, any such kind of data that you are getting, you are storing those data into the raw bucket. Even if you are getting some data in from the RDBMS or those kind of relational data, that also you are exporting and sending it here directly into the raw zone. Now from the raw zone, you are applying all the transformation. So when you have to apply the transformation, you need to understand what is the source schema, and then you map it to the target schema. Source schema, you don't know it because you can see here that there is no schema which is defined. The data are just getting dumped here. And that is the reason there is a separate layer of a catalog. In AWS, we have AWS Glue catalog service. Now what this service does, it goes into your raw zone, whichever destination you provide, it goes into those specific folders and crawl that folder. So whether it's a CSV file or a JSON or a text file, whatever is stored here in this raw folder, it understands the data and the structure of the data, and then it generates the catalog for that information. And this catalog information is actually going to provide the schema. And this schema is then used by the big data jobs. So big data jobs then are working here, which is like a Spark jobs which are there. This Spark jobs get the schema data from the catalog, fetch the data which are stored in the raw folder, do the processing, and then send the output result into the processed folder. So this is how the data lake works. Now, once the Spark has done the processing, either it sends the data to the process folder, or the Spark itself sends the data to the data warehouse. Other way is, once you store all the data in the processed bucket, from here you then load all this data into the data warehouse. Here also you can have the jobs. If I take the example of Amazon Redshift, Redshift itself provides the capability to read the data from this processed area and then load that data into the data warehouse. Data Lake also supports the near real-time live streaming. So whatever the data are coming here, they are getting processed, and through the live streaming, this data we are going to send it to the different AI/ML kind of endpoints. Plant is sending the MQTT messages, the IoT or the sensor data, to the data lake. From the data lake, we are doing the processing of that data, sending that data to the process folder, and from the process folder we are streaming that data to the AI/ML inferencing endpoint, and this AI/ML inferencing endpoint is doing the health prediction of the machine. Also, AI/ML needs a training. When the AI/ML needs the training, it can either point to the processed data which are stored here, or it can point even to the raw data if the raw data itself serves your purpose. Or if I take the example of Amazon Redshift as a data warehouse solution, this AI/ML training can even be able to train through the data warehouse directly. Now go back to the architecture. So here you can see that data lake has become as a central data storage. On top of that, the catalog is coming as a loosely coupled schema provider, which reads, crawls the data in the data lake, and then at the time of reading that data from the data lake, it get that schema information and then update those specific application. So even the data warehouse can also load the data directly from the data lake. The big data processing frameworks like Spark does the loading, processing, everything. And there are also interactive data queries where you write small queries, try to see exactly how they are fetching the data, are the data matching the expectation, and then only join those queries back to the Spark job. So these are the evolved architecture of the modern data lake. Because of now data lake is a storage area which is separated from the big data processing or any other kind of processing. So you can expand and you can add as much data as you want. Amazon S3, which is a data lake storage solution, it has literally no limitation how much data you can store here. Even the cost wise also, it's very less as compared to any other storage service. The moment you decouple the storage and the compute, you can scale your solution even to the exabyte. Second is all the data are in one place. So there are many such use cases where you need the data from different sources. For example, you may need the data from a CRM system, trying to understand what kind of customer trying to access your website. From the clickstream, you find which all links that person is clicking, and then you aggregate both this data and try to identify what all products, what all links you can recommend to that person. So those kind of use cases are possible because you are able to store all the data into one central location, and you would be able to apply aggregation of the data from all of those different data source. Real-time advanced analytics, I already mentioned about how you stream the data from the plant machine, and that data then gets processed and streamed into the AI/ML inferencing endpoint, which does the predictive analytics. Decoupling of storage and compute, I already covered. Schema on read, I also covered that using the catalog as a separate layer and using AWS services, which is AWS Group Crawler, how you enable the schema on read. Centralized governance, as I was explaining, that if you have a patient data in this raw area of your data lake, you can create different buckets, and every buckets you design it for different sensitive level. So if there are certain patient information which are highly sensitive, you can store them in a different bucket. Other general information you can store in a different bucket, like that. So storing it in a different bucket is one way of doing it. The other way is also the data mesh pattern. I'm going to talk about the data mesh pattern in the next video, but this is also one of the way that you can apply the governance into your data lake. And finally, the machine learning capability. I have already spoken about the predictive analytics of the machine health, and how do you call the AI/ML inferencing endpoint through the streaming of the data. We have covered the evolution of data lake from the legacy architecture. In the next session, I'm going to talk about first, what is the structure of the data lake, and second, what all are the different design principles and the design pattern of the data lake. So thanks a lot for staying with me, and I hope you have a good time understanding these concepts along with me. Thank you for your time. Bye bye.